We'll be talking about a different repetition structure today called for loops. For loops work a lot like while loops and do while loops, but you use them when you know exactly how many elements you are in an array. They're also more compact and they're easier to read as well. Now we're going to take a departure from our usual Windows Form applications, and we're going to create something called a console application. So inside your new project dialog in Visual Studio, where we usually pick Windows Form application, we're going to pick down here, third from the top, console. And I'm going to call this registrar. Now the first thing you're going to notice is that your Project Explorer here is very sparse. In fact, there's only one file, and that's program.cs. And what a console application is there's nearly no visual interface at all. In fact, it's almost just a process. You might have seen these, in movies where someone's running some sort of hacker thing, trying to break into a computer or running a bunch of scripts on a screen. From Windows, you can go to your Start menu and type CMD, and it's going to bring up what you would call command shell. Back before Windows and we had nice visual interfaces, everything was done through a command prompt or a terminal. And that's where Microsoft got its start, was through a product called DOS and later MS-DOS. This is not technically DOS, but it is a throwback, and it is a command script line. A modern version of this, still in use, is something called PowerShell, which we won't get a lot into, but that's also something that you can write .NET in and C#, which is a great tool. So command prompt, well, what's that all about? Well, it just runs a process without much of a visual interface. And we can have things output. We would call this the console. We have things output here. We can accept input, but there's no pictures, there's no resizable windows, there's no nice gradients and things like that. It's just a command prompt. And so what would that look like? Well, if we left this program just the way it is right now, and we hit start, or F5 rather, it's going to load up, and you'll see it kind of pops up really quick, and then it closes itself down. And that's how console applications work, is if you want the process to just run, it's going to run itself, and it will close itself down at the end. We don't have to do any application.close or anything like that. And this is great for certain processes that you might want to schedule. They don't take up as much memory because they're not loading any interface. They potentially could not require any user interaction. And so if you had, say, the need to check to see if your website was still running and you wanted to do it on the hour, you would write an application in here that went out and accessed your website. And maybe if the website's down, it would send you an email or send some sort of pop-up on a different screen. And then you would take that executable and you would run something called Windows Task Scheduler. If you type in task on your start menu and you go to Task Scheduler, I'm on a Windows 7 machine, that pops up, and what you can do in this Task Scheduler is add your own custom jobs. And I don't think I have any on here that I've done myself, but if you look, depending on what you have installed, Adobe Flash Player, this is what causes you to get those prompts that say, hey, your Adobe is out of date. Your Google software, if you have something installed locally, is going to ask you for an update for Chrome, for example. This is an HP laptop, so it goes out to HP and it checks that. You can write your own custom ones. And if you go on here, you can go to Actions, and it will even show you which executable it's running. And these are all console scripts. You only see a window running when it comes time to communicate something to you. And you see it goes Windows System 32 PCALUA.exe. That's most likely a console application, or potentially it's something that's written in Java or a different language. But we can do this with C#. But when we're learning how to do console applications, it's tricky because I'm launching it and it's just closing down. So So if I want the console to stay open, I have to make it wait for something from me. And one of those things that it can wait for is input from the user. Now everything that I do, either input or output, is going to go through this console. So I type console, then I type dot, and I'm going to pick read key. And then this is an actual function on the console object. So open and close parentheses, end with the semicolon. And now, if I hit enter, you're going to get that blinking cursor. And this was actually happening before, but it happened so quick, and it probably only happened once, that we wouldn't have noticed it. But now, basically what it's doing is it's waiting for me to press any key at all. So I can press spacebar or Q or enter. I'm going to hit spacebar, and now we would say this is a blocking call. It waited for something to happen, and then it resumed. Let's say resume the program flow after that. And since the application was over, it closed down. Now, this static void main, this is sort of like your form load on a Windows Form application. With one detail is that it happens every single time, and it happens when the program starts up. Now, we can run our own functions if we wanted to and have them go do their own things. But this is really the starting point to your application. This is your main. It's possible to accept arguments on the command line. If you've ever done anything in Linux, or if you've run any Windows commands through the console, you'll know that sometimes you write your exe, and then afterwards there'll be certain flags, certain arguments to pass in. And that's what that is. But we're not going to spend too much time on that today. So here's our simple application. Not quite a hello world just yet, because it's not saying anything. We know it's waiting for input, but we're not really doing anything yet. So let's change that. Before my console read key, I'm going to say, and I want to say something out to the console. I want to say console.writeLine. And we're going to have it say hello world. This will write out to the console. Now there's a write and there's a write line. Write will do the same thing that write line does, but at the end of the write line, it's going to return that cursor down to the next line. That blinking cursor that we see here is actually going to be on the next line. Now, this is great, right? We got the output going out to the console, but the user might not really understand what's going on or what to do next. So let's help them out, and we'll say console.write, press any key to continue. And so now when I run this, I have hello world, and then it says press any key to continue, and you'll see that the cursor is at the end of that line. And that's the difference between write line and write. Okay. So what's the point of all this? Well, I want to use this to illustrate a for loop. I'd like to take out some of the complexity of the forms. Also like to work outside of sort of the norm that we've been doing in all of these other lectures, in that this is another way of writing a .NET application. Not all .NET applications are form applications. Like I had mentioned before, there's some PowerShell. There's ASP.NET, which are web pages. There's WPF, which is Windows Presentation Foundation. Then there's the Windows mobile platforms, Windows 8 phones, Windows 7 phones, WinRT for Windows 8 stuff. So it's all the same language though. The presentation itself, we'd say the user interface can differ, but the syntax of the code itself that we're writing inside of Visual Studio is all going to be the same thing. That's why we say that you're learning C#. We don't call it a Windows form only. It's C# itself and ASP. .NET is something that's probably one of the other largest market shares on what people are looking for that. Okay, so press that out, and now what? Well, the whole point of this is for us to be working with for loops. And to make this interesting, we're going to have some data that we can actually loop through. So we're going to create two arrays. We're going to create an array of students, and we're going to create an array of those students' credits. So from a previous lecture, we had done something similar. So see if you can pause this video and remember how to declare two arrays, let's say of 5 students with corresponding information on credits. To do this, first we have to declare a type. We say string, and we would call this students. Now, our naming conventions with array types don't apply in that we want them to explain exactly what it is that they're doing. Anybody that sees the data inside the array is going to know what type it is. They don't need to necessarily see it within the name. So that's why we're not doing str students. Now, this would be how I would declare a single student, but to do an array of students, I give it a bunch of boxes. And I'm going to hard code the values in here. So just like we would do with a function, I give my start and close braces, and then inside I give them my name. So I'd say Tom. That would be a single element array, but we want more than that, so we separate out all of our values with commas. And so that would be an element array with 5 students in it. I want to make a corresponding credits array. Each credit is going to be a whole number, so I'm going to say int, give it a bunch of boxes, and say credits. Now, because each of these is corresponding with Tom or Susie or Tina, I want to make sure that I have 5 elements in here as well. So we'll do 96. There's not quotes around these because they're integer data types. There's no special notation that says we have to put quotes around array elements unless that array is of strings. And so each of these is going to correspond. So first element position, Tom, and we look at the first element in the other one. Susie, 76, Tina, 22, Jeff, 45, Paula, 110. So this is what I want my application to do. I want, when this starts up, I want it to output all of my students. I want them to give each of the students a number. And that will be sort of like a menu. And the user will be able to pick one of the students, and it's going to output how many credits that student has to the user. So we're going to get rid of our hello world here. And well, what do we do? Well, let's look at this. And this should always be how you approach looping structures, is rather than to just dive in and figure out the whole thing at once, look at one specific case. Because you have to know how to do it once before you can do it 10 times, for example. So what would we do? Well, we would say console.writeLine if I wanted to output Tom's name. And I could hard code in Tom, but that defeats the purpose of having our array. So I'm going to say students. And remember, we want the student at the first box. So because arrays start counting at 0, I say students 0. Now I'm getting an error here because of the way I've declared my arrays. Because of the way that console applications work, before strings we have to put a keyword here. Or arrays rather. I have to say static. And it's sort of, I guess the best way I could describe it is very similar to how we have to do public and private in our other applications. But for now, just put static in front of your arrays. And that's going to let the main method access them. Okay, now let's run it, see what we have. And it says Tom. Now we wanted to give some sort of menu structure in here as well. So we're going to want to put a number in front of our users. And let's stick with our zero-based indexing for now. And we'll hit any key to continue. And so we would give Tom a 0 and maybe do a colon in front of that to make it look nice. And then I have to do my string addition. So I'm essentially adding a 0 colon in front of Tom. And so there we go. Tom would be the 0 option on the menu. Let's do another one. I can copy and paste this line. And I can say, okay, the next one, 1, 1. So now we should have Tom and Susie. And we're starting to get this out. Let's put some instructions in front of all this. Let's say console.writeLine. Please enter a number to view the credits of a student. And this will give it a nice message along the top. Now we're not accepting any input yet, but we will. But first we need to think, well, this would work. I could technically do these lines 5 times, but we know that that's not efficient, and we would know that every time that we'd enter a new user in our array, we'd have to enter another line down here. So this is a great candidate for a looping structure. And what we would do with what we know already is we could do something in a while loop. A while loop needs a counter, a stop position, or a stop condition rather, and an accumulator. So let's declare our counter here. We'll say int I equals 0. And now our while loop and our stop condition. And we would say while I is less than, and we have 5 elements in our array. And so now, if I did this, it's going to output these lines 5 times. So what we want to do is we want to remove both of these and change it so that it can do it repeatedly. So instead of 0, I'm going to say I, because that's going to give me the element at the 0 position, at the 1, at the 2, at the 3, at the 4. And then here as well, instead of saying 0, I'm going to say I.toString, and then I'm going to sneak in my colon as well. So now this will be the same as what I had, but it should do it. Ooh, it's doing it a lot. And this is kind of nice because we can see that when we do it inside of a Windows Form application, it just freezes. But this is actually more showing you what infinite loop is really doing. And every single time it loops, it's outputting Tom to the screen. And it's pretty easy to tell too that what's happening is that it's staying at 0. And so every time the while loop runs, it's saying while true, while loops they continue on true, 0 is less than 5, true, 0 is less than 5, true, 0, and it's just going to keep going. So what we forgot to do is to do our counter. And so we say I plus plus. And now every time I is going to go up by 1, and there we have everyone inside of our array, just like we'd expect. Closing this down, one thing that we should fix is this length issue, because what we've done is, although we're looping through the array, it's not dynamically reading the contents of the array. It's always going to be locked in at 5, and if I were to add another user on, I'd have to change that number. So what we want is we want to go for students, and remember the array knows how long it is. So I'm going to say students.length. And now that's always going to give me the length. And now no matter what I do, whoever I add into the array, it's going to be dynamic in that it's going to read to the very end. Now while loops are great, but they're not the only looping structure. We've seen that already with our do while loops. And so instead, what we can look at is something called a for loop. And you would use a for loop for a couple reasons. It's more compact. The accumulator, the counter, and everything else are all declared within a single line. They're also, we would say, they're finite. While you can have a while loop, like we just saw, run forever, for loops will only run to a certain amount. So you won't get an infinite loop when you run a for loop. And infinite loops aren't necessarily a bad thing. We might be checking for something that we don't know when it's going to finish. We might be checking a value in a database and wait for it to change, and that could happen in an hour or it could happen in 20 days. And so a while loop would check it repeatedly until a condition is true. Remember, we say while true. A for loop, though, is great for when we know exactly how many times we have to run. In this case, students' length. So I'm going to comment this out, and we're going to do what it would look like inside of a for loop. And this is what that would look like. The same exact code that we just ran, but now in a for loop. I say for int I equals 0. Sounds familiar so far. Semicolon. Now this is all in the same line. I is less than students, not length, semicolon, I plus plus, close parentheses. Hit enter, opening curly brace, close curly brace. And so what we have here is we're declaring our counter. Here's our stop condition, and here's our accumulator. Oops. It's all in one line, and it's all happening right away. I don't have to spread it out here. I'm not going to forget to do my accumulator on the counter at the end. It's all in one line. You don't have to chase all over the application to see where these things are defined. They're all right here. And now inside the loop itself, I can copy this line out because we were using I, and it's exactly the same thing. So you're going to see the output's the same because essentially the logic is the same. But from a code readability standpoint, this works a lot better, and it's more specific to what we're doing. We're looping through an array. An array is finite. It has a definite end to it. And so that's what you would use that for. Now you could use a while loop here. If you like while loops, there's definitely nothing that would stop you from it. But generally, when you're looping through an array like this, you would use a for loop. So again, it's all, we would say this is all in line. This is our counter we declared. Here is our stop condition. And then here is our accumulator on our counter. Well, what should we do next? Well, we've output all the menu options to the user, and now we want them to actually pick. And so right now, what it's doing is it's going to close the application when we hit any key. So we don't want that. So what we have to do is we're going to put something after the loop, and instead of saying read key, we're going to do something called read line. We want to get the input from the user, and we want to actually do something from it. Read key will allow any key to be pressed, but what read line will do is wait for the user to press enter at the end of their input. So let's do this. We'll say string str input equals console.read line. And what this is going to do, it works a lot like try-parse in that it gets the input and it will place the value inside of string input. So now we have a string and we want to change it into an integer, which we also know how to do. So I'm going to declare an integer. I'm going to call it int input. We'll just start it at 0. And we're going to do a try-parse. int32 dot try-parse. There's no text boxes, but we have our string input out int input. Now that we have that integer, we can take that and write it back out to the console, but instead of just writing it, we're going to pull it out of the array. We're going to use that index that we just pulled out, int input, and we're going to pull that value out of the array. So we're going to say you selected student, and now we're going to add that on there, and we say students, and we're going to use that index int input. So this took the input from the user, did the try-parse, put it into the integer, and then used that to pull the value out of the student array. Okay, so it's waiting for us to pick someone. I'm going to pick Tom, 0, you selected student Tom. Looks like we have a little bit of formatting to do. That's okay. Hit any key to continue. It quit it. Let's run it again. Pick a different student. How about 4 for Paula? And we selected student Paula. So it's working. We wanted it to actually go and grab the number of credits though. So we're going to do a little more string magic down there. So let's take this here and let's put another line underneath it. And we're going to say, and now look, what we have here is we're pulling it out of the array. So we're going to do the same thing here. Students I plus, and now we're just finishing up a sentence here. Has, and then the number of credits. Credits, also same index. So we say int input. And now again, finishing out the sentence, credits. And let's see, we are missing a closing parentheses because this has an opening parentheses. So let's run it, and we're going to pick Susie. And looks like we need some carriage returns on here. So instead of doing right, let's do right line. And that's going to give us a nice carriage return at the end. So now again, we're going to pick Susie, and that looks good. So you selected student Susie. Susie has 76 credits. Press any key to continue. Excellent. Now, here's the problem though. We have an application that does exactly what we want, but every time we want to keep going, maybe I want to pick more than just one student, my program closes. So what we want to do instead is wrap a giant while loop around all of this so that I can keep running my application. So in the very beginning, I'm going to say while, and now if we wanted a while loop to run forever, remember whiles are while true. So instead of trying to give it some condition, I'm just going to say, hey, you're always true, keep running. Open curly brace, and at the very end, close curly brace. And so now you can tell by the indentation that all of this code is inside my while loop, so it should run forever. So I'm going to say 0 for Tom. You select student Tom. Tom has 96 credits. Press any key to continue, and there we go, it does it again. And now I'll say Paula. Excellent. Any key to continue. Jeff. Any key to continue. So essentially we have infinite application. Now I don't probably want an infinite application, but we're on a console app, so all we really have to do is hit the X key. Now it would be nice if we could clean this up a little bit. Putting this in front of all my code can get a little confusing. So I think what I'm going to do is I'm going to put it inside of a function. I'm going to say static void because that's what we're doing inside of our consoles, and I'm going to say student menu. That's the name of my function. And now I'm going to take everything inside of my while loop, everything, right here, put it inside of my function here, and now in my main, I'm just going to say student menu. And so now what you have in your main is you have your application flow, your program flow. And I can see that what's happening here is whatever student menu is, it's going to run it forever. And that's what's going on here. It's running it forever. But it's easier to tell that because what we've done is we've placed all of our, we'd say our application logic, we've placed it in a single function. And we've named it accordingly to what it does. So this almost reads like a story here. We're saying while true, which we know as developers that that's an infinite loop, run the student menu. Now we see this and we say, oh, well, what's student menu? Well, we can go right click and go to definition. Maybe it's a big program, and we can say, oh yeah, okay, it's actually looping through everything in these arrays and it's letting the user pick something. And so this is how we do program flow typically. So we like to see what's going on, and that's why we give our functions names on what it is they actually do, because you can read it like a story, and then if you want to see the details, then you go to the function and you actually take a look at what's going on. Now this is awesome, but again, I don't really want an application that runs forever, so what we can do instead is we can test for what key has been pressed. And so we would do something like this. We'd say string, let's just call it str menu, make it an empty string, and we're going to say this, while string, we want true, while string menu does not equal Q. Oops, Q in quotes, because it's going to be a string. There we go. We're going to run the student menu, and then at the end we're going to say this, console.writeLine, and we're going to say press any, actually that's not true, we want to enter any value to continue, Q to quit. And so we're going to give the user an option of entering Q to get out of here. Then we have our input, so we say string menu equals console dot read line. And now what's going to happen is it's going to take that value, it's going to put it in here, and then in the beginning of our while loop, it's going to check to see if it's Q. If it's not Q, this evaluates to true, and it's going to keep looping. Now in our function, we want to enter in, we want to comment these out because that's going to fight what we're doing. So let's try it now. Enter a value in 3. You selected Jeff. Jeff has 45 credits. Enter any value to continue, Q to quit. Let's type in a W. And then it's asking me again. Great. Let's do Jeff again. And then let's try Q, enter, and it's done. Probably would have put a semicolon and make that look nice at the very end. So now we have an application that could potentially run forever, but if they don't want it to, then they hit Q. And this is exactly the difference between a while loop and a for loop. This has the possibility of running forever, but our for loop, we only want it to run once for each element in the array. Now we have one more thing to fix in our application. That's a user interface kind of thing. When we run it, we see that it starts at 0, 1, 2, 3, and 4. And that's great. We know that it has something to do with our 0 counting, but users don't like that. They say 0. Well, what's a 0? Nobody ever asks you 0. It's always 1, 2, 3, 4, 5. And so for the sake of our users, we want to offset this. Because users don't like counting at 0. Developers do, because we have to, but that's not quite what we want. So the first step we have to do is in our output. Now, one thing that we've been talking about this whole time is that when we do something, for example, like here in our while loop, in between the parentheses, we always say that that evaluates out to a certain value. We know that we're using the not equals operator, and so that's going to evaluate to a true or false. When we do some sort of equation, let's say I did int x equals 4 plus 6, we know that this evaluates out to a value of 11. Because it's math, we can wrap parentheses around it. And the way .NET treats this then is that whatever this value is, you can actually have that as almost its own variable. And when you wrap parentheses around it, you can treat it like a variable, so we can start doing things like toString, for example. It treats it as if it's its own value, and we're going to use that up here. So instead of I, which is great, we don't want to change that, but what we do want to change is the output. So I'm going to wrap parentheses around that I, like we didn't have enough parentheses already, and I'm going to sneak a +1 in there. And now this doesn't permanently add it. I++ permanently adds it to each loop, but I+1 is just going to evaluate to 1 more than our counter. And now I'm going to hit F5, and you'll see that the offset has indeed taken effect inside of my menu. But the problem with that now is that if I hit 1, 1 is going to be Susie. And so although the menu is proper, our input isn't acting accordingly. So what we got to do now is, after we get our input, we have to subtract 1 from what the user actually wants. So we're just going to do this. We're going to say int, my cap locks on, int input equals int input minus 1. And we would say adjust for menu offset. And so now when the user enters 1, our application is actually going to treat it like 0. When the user enters 2, it's going to actually treat it like 1. And so now if I hit in 1, we're going to get Tom. Hit in Susie. 2, we're going to get Susie. Hit in 3, we're going to get Tina. So everything's working great. We have a nice solid application here. Now, one more thing I think we could put in here, for example, is what if someone typed in 6? Well, if someone typed in 6, it's going to crash my application, or rather it should have. There we go. So what we should probably do is in here, we'd say if, pulling in some old code here, int input is less than 0 or, oops, oh, wrong language, sorry, or int input is greater than or equal to students.length, we're going to say console.writeLine, please enter a valid menu option, else do what we were doing before. And this will make sure that we have actually items that are in our array instead. So if I come in here and I say, 67, that's good. If I came in here and I type -1, then we're good, and it's going to keep our application from crashing. So there we have it, for loops. And this is a great example of it because we have this while loop in here, which technically could be infinite, and we have our for loop in here, which is finite. Now, you're going to see more developers use for loops because they're more compact. You don't have to chase down where all the variables are being declared and incremented, and it just reads better. But you'll use your whiles and your do whiles when you don't know how many times your application and your looping logic actually has to run.